Imagine looking on the horizon and seeing the sunrise fill half the sky. Neil deGrasse Tyson reveals that Betelgeuse just exploded, and something terrifying is happening. Home to over 200 billion stars, our Milky Way galaxy is expansive and mysterious, yet there are moments when it seems to draw us in with an irresistible pull. One such moment is the current terrifying events happening with Betelgeuse, a red supergiant star only 650 light-years away. Located on the left shoulder of the Orion constellation, Betelgeuse is one of the brightest stars in our observable universe, often undergoing variations in its luminosity. A recent fluctuation in Betelgeuse's luminosity, with an astonishing 50% reduction, has convinced astrophysicists that we are about to witness the ultimate cosmic spectacle. Scientists and astronomers agree that the events happening with Betelgeuse are harbingers of the star about to go supernova. However, the exact timing of this event is still uncertain. Betelgeuse's proximity to Earth makes this terrifying because we could potentially witness an incredible change that many on our planet will never get to experience. Betelgeuse, also referred to as Alpha Orionis, is typically the 10th brightest star in the night sky and the second brightest star in the Orion constellation, indicating the hunter's right shoulder. This red giant star is unique among the prominent stars in Orion, which are mostly bright young blue giants or supergiants. Along with stars like Rigel and the Orion Nebula, it creates a visually stunning celestial image in our Milky Way galaxy. However, Betelgeuse's role in astronomy extends beyond its beauty, as it has helped us learn more about the astral life cycles of massive stars. The diameter of Betelgeuse is about 1,000 times that of our Sun. If it replaced our Sun, its surface would extend beyond Jupiter's orbit. Its size means that we can see it with the naked eye, and its color difference from other stars in Orion is visible to those with sharp eyes. However, Betelgeuse occasionally moves up or down in the brightness ranking due to its cyclical dimming and brightening. Despite being only 10 million years old, making it 50 times younger than our Sun, Betelgeuse has already used up all its hydrogen fuel and is in the later stages of its evolution, fusing helium to carbon. Recent news about Betelgeuse has been terrifying, explaining the variability in its brightness over the last few years. Astronomers have observed Betelgeuse's brightness to wax and wane on a regular 400-day cycle for centuries. However, in December 2019, the star abruptly became 2.5 times fainter than previously observed, a 50% reduction in luminosity. This intense reduction caused scientists to speculate that something terrifying is imminent within the star. This last instance of dimming, now referred to as the Great Dimming, was determined to be caused by a massive material explosion from the star's interior, resulting in a massive dust cloud that blocked our view. Betelgeuse has not returned to its old self since the dust cloud vanished. The star's 400-day brightness oscillation cycle has been cut in half to 200 days, and starting in the spring of 2023, it became brighter than usual at its peak luminosity. These changes have led most scientists to agree on the possibility that Betelgeuse will soon go supernova. Supernova explosions are incredibly large stars' last moments. Red giants start burning carbon and oxygen into neon and magnesium, then burn those into silicon after using up all the helium in their cores. The centers of the stars eventually become iron-rich, and adding helium nuclei to an iron atom extracts energy rather than releasing it. As a result, the star's core begins to absorb energy, leading to a core collapse. Supernova explosions can briefly outshine entire galaxies due to their extreme brightness. Betelgeuse's supernova explosion, due to its proximity, would be so bright that it would be visible during the day. At just 650 light-years away, humanity is perfectly positioned to witness this cosmic event. A massive star like Betelgeuse exploding will produce a stunning display of light that could reach 100,000 times the usual luminosity of the star. Initially, there will be a sudden influx of neutrinos detectable by observatories worldwide. The light produced would result from high-energy photons escaping from the rapidly expanding cloud of star debris, rivaling the brightness of a full moon. Because of its proximity, Betelgeuse is one of the few stars that can be investigated more closely by telescopes on Earth and in orbit. According to top theoretical astrophysicists, other than our Sun, most stars cannot be researched in any depth. We only notice them as single points of light. However, Betelgeuse is large enough for the Hubble Space Telescope and radio telescopes to resolve it. These pictures show a fascinating body that's very unlike our Sun. Betelgeuse is not a single smooth sphere of extremely hot plasma. Rather, it's a lumpy cluster of bubbling gas. It spews enormous plumes of heated material that rise to the surface before cooling and returning to the interior. Betelgeuse has a relatively symmetrical photosphere, the outer layer from which light is emitted. However, its photosphere showed significant disturbances and was expanding at a constant rate until mid-November 2019, when the outward velocity started to reduce. When the outflow of material from Betelgeuse stopped, astronomers captured optical images revealing new anomalies. The southern hemisphere of the star showed a newly formed darkened region, and its surface temperature had dropped by 80 Kelvin. These changes were visible to telescopes and the naked eye. Detailed observations with instruments, like the sphere on ESO's Very Large Telescope, showed a significant reduction in brightness by a factor of 2.5, reaching its lowest recorded brightness with a magnitude of +1. Nearly a year after the outflow cessation, the star regained most of its previous luminosity. Astronomers hypothesized that a large dust cloud obstructed the light emitted from the star. However, further analysis could not prove this hypothesis. Another proposed hypothesis was that Betelgeuse, a variable star displaying luminosity variations over time, underwent a series of pulsations or instabilities in its outer layers, causing the brightness change. This hypothesis was supported by the presence of massive convective cells on the star's surface, similar to those in a pot of boiling water. The exact timing of Betelgeuse's explosion remains uncertain, with varying predictions from the scientific community. Betelgeuse, a red supergiant star located in the Orion constellation, has been a subject of intense observation and study due to its significant variations in brightness and its potential to go supernova. Betelgeuse's unpredictable behavior has led to numerous hypotheses about its future. Some researchers suggest that Betelgeuse is nearing the end of its carbon-burning phase. This stage is critical in a star's life cycle and signifies that it is approaching its final stages. When a star exhausts its carbon fuel, it begins to burn heavier elements until it eventually accumulates iron in its core. At this point, the core can no longer produce energy through fusion, leading to a catastrophic collapse and subsequent supernova explosion. If Betelgeuse is indeed nearing this stage, it could mean that we are on the brink of witnessing one of the most spectacular events in our galaxy, the death of a massive star. However, other scientists believe Betelgeuse is still in the early part of its evolution. According to this perspective, the star has several millennia left before it exhausts its fuel and undergoes a supernova. This viewpoint is based on models of stellar evolution that consider the complex processes within Betelgeuse's core. These models suggest that Betelgeuse might still be burning helium, delaying its transformation into a supernova by thousands of years. Adding to the uncertainty, scientists at Harvard University have predicted that the supernova explosion of Betelgeuse could be tens of thousands to 100,000 years into the future. They argue that Betelgeuse is still burning helium at its core, a stage that precedes the burning of heavier elements like carbon, neon, and oxygen. According to these scientists, Betelgeuse has not yet reached the critical point where iron accumulation would trigger a supernova. This prediction is based on current theoretical models and observational data, but these models have inherent uncertainties. The debate over the timing of Betelgeuse's explosion highlights the complexities of stellar evolution. Stars like Betelgeuse undergo numerous changes throughout their lifetimes, influenced by factors such as mass, composition, and internal processes. Predicting the exact timeline for these changes is challenging, especially for a star as massive and variable as Betelgeuse. Recent observations have added to the intrigue surrounding Betelgeuse. In December 2019, astronomers noted a significant dimming of the star, which became 2.5 times fainter than usual. This unprecedented dimming event led to widespread speculation about the star's future. Some scientists hypothesized that the dimming was caused by massive ejections of material from Betelgeuse's surface, creating dust clouds that temporarily obscured its light. Others suggested that it might be an indication of more profound changes occurring within the star, potentially signaling an approach towards supernova. Betelgeuse's proximity to Earth at just 650 light-years away makes it an even more compelling object of study. If Betelgeuse were to go supernova, the explosion would be visible from Earth even during the day and could shine as brightly as the full moon. This proximity allows astronomers to observe Betelgeuse in greater detail than many other stars, providing valuable data to refine our understanding of stellar life cycles. Despite the differing opinions, there is a consensus that Betelgeuse will eventually go supernova. When this happens, it will be an extraordinary event, offering insights into the life and death of massive stars. The explosion will release an enormous amount of energy, outshining entire galaxies for a brief period. It will also produce a wealth of heavy elements, contributing to the cosmic abundance of these materials, which are essential for the formation of planets and life. In the meantime, astronomers continue to monitor Betelgeuse closely using a variety of telescopes and instruments to gather data. Advances in technology and our understanding of stellar physics will hopefully provide more accurate predictions about when Betelgeuse will finally explode. Until then, the star remains a source of fascination and mystery, a reminder of the dynamic and ever-changing nature of the universe. Despite the uncertainty, Betelgeuse's immense size and brightness remind us of the vastness of space and the cosmos. A single star's impact on our perception highlights the insignificance of individuals in the grand scheme of things and the awe-inspiring nature of the universe. As scientists delve deeper into the mysteries surrounding Betelgeuse, new questions arise about its behavior and potential future. Recent observations have provided tantalizing clues, but they have also raised further uncertainties about the star's fate. One of the key puzzles surrounding Betelgeuse is the nature of its variability. While fluctuations in luminosity are not uncommon among stars, Betelgeuse's extreme dimming events have puzzled astronomers. The sudden and dramatic reduction in brightness observed in December 2019 has prompted intense scrutiny and speculation. Some researchers have proposed that Betelgeuse's variability may be linked to its pulsations or instabilities in its outer layers. These phenomena could result from complex interactions within the star, leading to periodic changes in its brightness. However, the exact mechanisms driving these fluctuations remain unclear. Other scientists have suggested that external factors, such as massive ejections of material from Betelgeuse's surface, may be responsible for variability. These material ejections could create dust clouds that temporarily block the star's light, causing it to dim. While this hypothesis offers a plausible explanation for some of Betelgeuse's dimming events, it does not fully account for the observed patterns of variability. Further complicating matters is the possibility that Betelgeuse may be undergoing significant changes in its internal structure. Recent observations have revealed anomalies on the star's surface, including darkened regions and fluctuations in surface temperature. These observations suggest that Betelgeuse's outer layers may be undergoing dynamic transformations, which could have implications for its future evolution. Despite these uncertainties, astronomers remain vigilant in their monitoring